Alright, in day 8 we're going to talk about inscribed polygons. And what that means is that we have a shape that is entirely inside a circle. Like the inscribed angle was inside the circle. An inscribed polygon is a shape that will be in the polygon. So we're going to focus on triangles and quadrilaterals. So in these diagrams down here, all the triangles are right triangles, and we can use what we know about right triangles in arc measure to solve these problems. So if we look at A, this is a 90 degree angle, one because they tell us, and two because the arc that is formed is a semicircle. So you see how line CB is a semicircle, and what we learned the other day was that the measure of that inscribed angle right here has to be half of that arc measure. Well, half of 180 is 90 degrees. Okay, so we know that that's 90 degrees. Right here we have a 50 degree angle, which makes this angle 40 because 40 plus 50 plus 90 is 180. So angle ACB is 40 degrees. Oops. Now the measure of the arc CAB, that arc is this right here, and that's a semicircle, so that is 180 degrees. And then the measure of arc AB, well, AB is just this part right here, so we have to look at that inscribed angle, which is 40 degrees, so the arc measure is 2 times 40, or 80 degrees. Now letter B, we're going to do the same way. Because this is a semicircle, that means the inscribed angle right here is 90 degrees, so it's a box. So angle ACB is 90 degrees. Well then, this angle up here, angle CAB, we have a 64 degree angle, we have a 90 degree angle. So if we do 180 minus 90 minus 64, this needs to be 26 degrees. Now with that, we can find the measure of arc AB. We already said that the measure of arc AB was going to be 180. And the measure of arc CB, well, if we look at the angle that goes with that, the inscribed angle, that's the 26 degree angle. So 26 times 2 is 52 degrees. Then example C, again, this is a semicircle, which makes this angle right here 90 degrees. So then these two angles have to add up to 90 degrees for that whole triangle to add up to 180. So we have 1/2 x plus 1/3 x plus 5 equals 90. I want to subtract 5 from both sides, and we get 1/2 x plus 1/3 x equals 85. So what you can do here to get rid of all these fractions, you can multiply everything by the greatest common factor of 2 and 3, which is 6, because 2 times 3 is 6, so I'm going to multiply everything by 6. And what that gives me is 6 times 1 is 6 over 2 is 3, so 3x plus 6 times 1 again is 6. 6 divided by 3 is 2x equals, and then we can use the calculator for 85 times 6 is 510. And then we will solve that. 5x equals 510. You combine it in your like terms. Divide both sides by 5, and x will be 102. So x is 102. And then the measure of angle ACB, again, would be 90 degrees. All right, let's look at example 2. It says a right triangle is inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? So we need to draw this. That's a terrible circle, so I'm going to draw a better one, or attempt to draw a better one. Okay, so there's our circle. It says a right triangle is inscribed in it. So if we're going to draw a right triangle, the hypotenuse needs to be a diameter. That will ensure that this is a right angle here. It says that the radius is 5.6. Radius 5.6. Well, any radius is also going to be 5.6. That means this hypotenuse is going to be 5.6 plus 5.6, because the hypotenuse and the diameter are the same length. And when you do that, you get 11.2 centimeters. Alright, so we can use that information to apply this to quadrilaterals. So in this picture, you see we have this angle right here goes with this arc, and then we have this angle here that goes with this arc, and you see that if we were to combine those two arcs, we get the full circle, and the full circle is 360 degrees. Well, since these angles are inscribed, this is an inscribed angle, and this is an inscribed angle, and they together form the whole circle, that means that these two angles have to add up to 180, because the inscribed angles are always half the arc measure. So those angles add up to 180, and we know that as supplementary. And they would add up to 180 degrees. And it has to be true for both sets of opposite angles. So if we were to look at this and I were to use the other two angles, so this angle right here makes this arc, and this angle here makes this arc, and again both arcs create the full circle. So this must be true for both. Let's draw that back in real quick. Alright, so on the next page, we're going to determine whether these quadrilaterals can be inscribed in a circle. So that would mean that these two angles have to add to 180, and these two angles would have to add to 180. Now yet we don't know this angle down here, but I can already see that, 130 plus 70 is 200 degrees, not 180. So no, 130 plus 70 is 200. They're not supplementary, so this quadrilateral can't be inscribed inside a circle, because for that to be true, the opposite angles must add up to 180 degrees. Now in letter B, remember the boxes are 90, so that works. These two angles add up to 90. Now we don't know what these two angles are, but because this is a quadrilateral, we know all the angles have to add to 360. So if my two green angles here add up to 90, that means the two purple angles have to add up to, if the two green angles add up to 180, that means the two purple angles must also add to 180. So yes, the opposite angles are supplementary. And then the last one, we know that this is an isosceles trapezoid because we have one set of parallel lines and the two legs are congruent. And what that means is that these two base angles are congruent. So this is 120 as well. It also tells us that these two angles should be supplementary because we have two parallel lines cut by a transversal. So these are consecutive interior angles. So these angles up here must be 60 degrees and 60 degrees. So yes, the opposite angles add up to 180. So this isosceles trapezoid can be inscribed in a circle. Yes, opposite angles are supplementary. Alright, in example 4, I'm going to do letters A, B, and D, and then I'm going to have you try C and E. So in letter A, we have these two that should add up to 180, and these two angles that should add to 180. Now, because these are both 62 down here, that means these two angles up here should also be the same. So we can do x plus 62 equals 180. Then x is going to equal 118 degrees. And since y is the same thing, y will also equal 118 degrees. Alright, in example B, what we first need to do is see what we're given. We have angle x right here. And angle x goes like that. And you can see that the arc that goes with angle x is this whole arc right here. So we have 170 plus 40, which gives us 210. So that means angle x has got to be 1/2 times 210, or 105 degrees. Alright, now that we know that angle x is 105 degrees, for angle y, we can do 180 minus 105, and that gives us 75 degrees. So y equals 75 degrees. And x was 105 from up here. Alright, now letter D. For this problem, I'm going to start with x, because I see we have this angle here, and that makes, just like in the previous problem, this entire arc. That arc, once you add it up, is going to be 183. All right, now, because angle X is an inscribed angle, we know that angle X should be half of 183. So if we do 183 divided by 2, so X will equal 1/2 times 183, and that equals 91.5 degrees. Now these two are opposite angles, so they must add to 180. So to find out what Z is, we can do 180 minus 91.5, and that equals 88.5. So Z equals 88.5 degrees. And X was 91.5 degrees. Now for Y, these two angles add up to 180. So 2y plus 3y plus 5 equals 180. Combine your like terms. We get 5y. And I'm also going to subtract 5 from both sides. So 5y will equal 175. Then when I divide both sides by 5, y is equal to 35. Okay, so use these three examples that I did to go ahead and try letters C and D, and then once you've done those, unpause the video and check with what I got. Okay, so let's look at C. I got 23.25 for X. And then for E, I got X was 39 and Y was 29. So hopefully you did well on those, and you're good to go on this stuff. All right, let's look at the last example on the next page. So it says, in the star below, all the inscribed angles are congruent. Find the measure of an inscribed angle, and then find the sum of all the inscribed angles for the star. Now, if all the angles are congruent, okay, what that means is that all these arcs are also congruent. And we have 5 equal arcs, and the whole circle adds up to 360. So the area of one arc is 360 divided by 5, which is 72 degrees. So each one of these arcs is 72 degrees, which means the inscribed angles down here, each one of these is equal to half of that. So inscribed angle is half of 72 is 36 degrees. So that's the first part. It says find the measure of an inscribed angle. Then it asks us to find the sum of all the inscribed angles. You could go about this two ways. You could say, well, there's 5 angles, and say 5 times 36. 5 times 36, and we get 180 degrees. Or you could have said, well, all these inscribed angles, if you look at their corresponding arcs, you get the whole circle, and the whole circle adds up to 360 degrees, so all the inscribed angles need to add up to half of that, or 180 degrees. So either way is okay. So, if you need to review this lesson, go ahead and do so. Otherwise, I will see you later.